All right, let's do this. My name is Frans. I'm from Detectify, which is security for developers. Anyway, does anyone remember this? It was a couple of years ago. A guy named Weave actually went out and said that he had a bunch of user credentials or email addresses and account information from AT&T using iPad. He got in jail, 41 months, and he actually didn't expose anything. He just told everybody he had it. And maybe you remember this one. The Apple developer platform actually went down a couple of days because a guy named Ibrahim Balik went out on YouTube with a video showing that he could fetch all the email addresses for all the developer accounts. And he was a friendly guy, actually. He told Apple and everything. They didn't care. And suddenly he went out with a YouTube video and stuff happened. So everybody was affected by that because you couldn't really deploy any apps or anything for a couple of days. So what does these two have in common? It's something called insecure direct object reference. You might have heard about it. It basically means that you're exposing data without a proper access control. So who am I to talk about this? Well, I'm a knowledge advisor, so to say, at Detectify. We're based in Stockholm. I blog around security issues. And how many of you guys know about HackerOne, or girls? One. Interesting. All right, I'll come to that later. So I'm number 2 on HackerOne. Doesn't mean anything to you guys now. But I hacked a bunch of companies also. All of these companies has something called responsible disclosure, which basically means that they allow you to hack them if you tell them first. And some of them also allow you to actually go out and explain what you did as soon as they fixed it. And some of these companies, I would say most of them, are actually paying money if you tell them something that they also agree on is a security vulnerability. And they pay a lot of money, and I'll get to that. So, insecure direct object reference, how bad is it? There's something called OWASP. I think more guys here or girls know about OWASP more than HackerOne, I think. Yeah. So OWASP releases a top list of the most common vulnerabilities for the web, like every other year, and it stays on number 4. I think it went up like 2015 list. But it's always been like pretty in the top of issues. So, what is it? Here's an example, an e-commerce, and I placed an order. And this order shows me, this page shows me a URL, and that URL tells me that I'm viewing a receipt and for an order number with 45345. And you can see all my information. You can see like my credit card details. It's hidden, but it's still there. But what happens if you modify that ID to something else? Let's lower it by 1. And suddenly you see something else. This is nothing that is like rare out there. This is extremely common. Extremely common. Here's a real-life example, and you might facepalm to this because it's madness. And I won't tell you who did it, Oculus. But anyway, so update a user, totally legit. What happens here is basically you insert the email and password. But in the cookie, there's a user ID in the request with my user ID. Looks good. My user is updated. Well, let's change that to something else and add a new email with a new password, and suddenly another user is updated. And you could probably see the business impact of this. So apart from like modifying or actually fetching keys and passwords, you could also fetch some credit card data, often obfuscated, but still you can get some billing addresses, you can get some prefixes. You know about this maybe like Amazon and I think it was Amazon and Google or something. They show different suffixes of the credit card, and you can use one of them to lock up the other one. I think well Apple and Amazon actually. User information, email, really extremely common. And the most common, I would say, is like invoices and billing data. Imagine having a platform where you are able to download invoices, the old ones, and you have a URL telling, show me invoice number 45, and you change that to 42, and you see someone else's data. The not so obvious business impacts to this is that numeric IDs are the worst. Like, they are not that great to use. And the idea behind it is that numeric IDs exposes both the range of new IDs creating. Like, if you have a community or something and you want to pretend to be huge, and you create user IDs numerically and incrementing, you will start to figure out that, hey, there's not that many people here, because it's just 4 digits. And you can use this data. You can actually, like, you can calculate on competitors, how many orders are they, like, getting per day on their e-commerce. If you place an order, or like you prepare an order or something and you see an order number, and then you go back 2 days later and you see the difference, and you can start calculating on that. And that's worth money. Also, not found and no access is a really common thing. Actually, the REST specification says that you should, and they actually modified it pretty like lately, say that you should show you different error codes depending on if the data exists there and you don't have access to it, or if it doesn't exist. And this actually exposes a lot of data as well, because you can then tell that, hey, this ID actually exists here. So if I can manage to get it somehow, I actually can use this as a verification. This was also used as, like, if you know the Ashley Madison hack recently. They exposed, like, a lot of user data, but one guy, Jeremiah Grossman, he actually realized that if you just go into the site and try to register with an email that already exists, it tells you that it exists. So it's, and that's extremely critical due to the site. So, even worse. And this is real life examples. This is so sad to tell you that this is actually out there. So a lot of e-commerce website actually allows you to change the delivery address after the order has been placed. This is really good because you might use PayPal or something and it puts in the shipping address from there, and you're able to change it in a later stage as soon as you place the order, like until it's been pick and packed and sent over. And this is extremely common also, that you modify this delivery address and it sends in the order number, and you modify the order number and you modify someone else's order. And one good example of that was one site selling student literature, like old books from other people. And the order IDs was like secret. You couldn't really find them. But the customer service on Twitter, they like, please send us your order number. So you could just like look at the tweets to them and take the order numbers and then just modify them and change the delivery address. They were pretty happy that I found that. Deleting other users' information. Deleting is something that you do a lot of unit tests, or you build a lot of tests of the flow and stuff, and you like skip the deleting part because it feels like, yeah, that probably works. And that's also really common, to change the ID of something, deleting, and suddenly someone else's data is deleted. And reclaiming others' users' data. Also a great example. Gift certificates is stupid by itself. So basically, gift certificates is commonly, you can see that if you buy gift certificates and stuff, you can always see that they're numeric. And you just change the gift certificate information and you get another gift certificate. You can buy a lot of things with with those. This is fun, right? Internet is fun. So, with this in mind, could everybody that feels totally protected by this raise their hand? So, why so few? Because there were none. Access model. Access model sucks. I hate access models, and a lot of people do. Because it's really easy in the beginning. Like, you have a user that should have access to an object. Super simple. Like, check if the user owns this object, and then it's fine. But then the object can have like children objects. And then the children objects can have a specific URL for them only or anything. And then you need to like traverse the path back to the user. And as soon as you start working with multiple levels of that, it ends up in being really complicated. And that's one of the reasons why this is extremely common. Another reason is the numeric IDs. Enumerable, sequential, decrease in value with one and try. It's extremely easy to test for it, and extremely easy to attack. Also, I heard about one solution to that is use hashes, like hashes or UIDs. But I heard about one example, actually, just taking the numeric ID of the database and just hash that. So it was a number anyway, but it was just an obfuscated number. So you could just make a hash of 1, 2, 3, 4, 5 and use that because that's more secure. It's not. Like, it's not. But people do that, so don't. Another reason is error messages show and tell, as I told you with the REST case. I've even seen an example of this, like user X cannot view the object because it's owned by user Y. That also is like business sensitive data, because then you can realize, okay, so how many objects does user Y actually own? And you can start mapping up that really easily. Also, the no access to this object versus the object does not exist is also a reason. And that's also an indicator. Like, if you approach as a target and find these issues with no access and object does not exist, you realize that, hey, they are probably having a lot more issues behind this than only this. Another reason is the inconsistent ID sources. You can make like an assessment for a website or a pen test for a website, and you see really nice routes. They look really good. Everything is great. They have a receipt/view and the ID, and everything is going through their access model. But suddenly you see one request that has the ID in a different variable name in a post request or something. And suddenly you realize that, okay, so probably there's a bunch of developers here on the back of this application. So the creators of this actually created a really nice access model, and it was beautiful. But the problem was that they hired some new guys, and they hated this access model. So they just bypassed it because it was a mess. So they created their own way to because if we rename the parameter, the access model wasn't used. So they used that, and hey, my application works, and they send it out. And suddenly you realize that, and you find that, and you change something, and you see that, hey, this is actually affecting, this is actually bypassing the access model. Another reason is one of the most important things, I think, lack of proper code review. I'm from Detectify, so what Detectify does is basically trying to build automation around security issues. So we collect, I'm one of the guys that try to collect all the information around what security issues are out there, so we can actually automate a lot of stuff. And this is one of those vulnerabilities that is really hard to actually automate and make it scalable. Like, you can make that, you can automate it for your own site because you know what information that is sensitive. And you know what objects that should not be exposed to anyone. But imagine a Bitcoin site. Like, Bitcoin transactions is globally available. Like, they're not restricted. So if you're able to see a transaction on a Bitcoin site that is not yours, that is not an important thing. That is not severe. Like, that is how it's supposed to be. But imagine having a bank site, seeing other people's transactions. That is a big no-no. Like, that is something that you I will move this one. That you should not see. So it's really hard to make it generally automated. And lack of proper code review is one of the reasons why this is just an issue. Because if you start talking with people and explaining what you're doing, you will realize that, hey, but you're bypassing our access model. Like, people tend to do this really good in the beginning, and then it ends up in being just, we need to get the product out. We can't really wait. We just ship it. So, examples. Bring the popcorn. No popcorn here. No. All right, so back to HackerOne. HackerOne is actually a platform for companies that can allow you to, it's like a marketplace. So Twitter goes there and said that we're going to pay you money if you can find security issues on our site. And if you do, we're going to pay you money on a denominator of 140, because that's our characters. So they always use that denominator. Depending on the severity, you get, like, in this example, $2,800. And in this case, so basically this is one of the reports that is publicly available on HackerOne. So you're able to go inside HackerOne and see the reports for example, Twitter. They expose what they've been vulnerable to before, which is extremely good for like building knowledge. So this case is a friend of mine called Ahmed. He actually found one of these IDORs, if we can like call it that. So basically Twitter has an ad platform. And on the ad platform you add your credit card, and then you add your advertisements. And depending on how much you're advertising, you're going to charge your credit card. What he found was that if you try to delete your credit card, it uses a numeric ID for the credit card. And if you change that, you remove credit cards for other users. Which is extremely good if you don't like ads, but it's extremely bad for Twitter. And so basically he could delete all of the credit cards, and suddenly no ads appear on Twitter. And they actually paid him for it, because they fixed it like super quick, because it's bad. Another example is one of my reports for Square. If you don't know what Square is, it's basically like a POS solution for small businesses. So you can have an iPad and you can charge with credit cards and stuff. So what they had was basically you added a lot of users on the platform. When you register for Square, you can add your employees and stuff, and you can give them credentials to modify products or modify orders or handle orders or look at reports. And the user IDs was actually hashes, which was great. However, if you Googled for a specific store website that you could manage your own, like you could create on square.com or squareup.com, you could create like a store website. And that one exposed the users of that company. So if you had that user ID, which was a hash, you could actually modify the user information for those users. And that means that if you change the email to your email, you will see their information, which is not good. So they actually fixed it super fast and also paid like $3,000. I haven't converted this to pound, but you'll get it, right? So Oculus, they actually released like, and not only responsible disclosure, it's also called like a bug bounty. That's the term when paying out money. So Oculus released a bug bounty like a couple of months before they were acquired by Facebook. And then Facebook, which has always had a bug bounty, at least for a couple of years, they included Oculus into their bug bounty. They pay you really good money for issues, even though the Oculus was an acquisition. So another friend of mine called Bitquark, he found a lot of stuff at Oculus just right before, or just right after they were acquired by Facebook. And one of the big issues in Oculus was that everything was numeric IDs. So he was actually able to make a remote code execution, which is like game over for the site. It's like, that's the worst thing that you can actually do, probably. And one of the reasons was that you could add yourself into a group, but you could modify that group to whatever group you wanted. So we added himself to the admin group, and the admin group got credentials to publish PHP files on the server. So that was, yeah. And the bounty in total, I think it was like 3 or 4 bugs that made him do the whole flow, and that was $25K for it, which is extremely good for the amount of time that he actually spent on it. So, doing it right. User IDs should not be placed in cookies. that is. I hope you all agree on that. So keep it in sessions, keep it in tokens. Tokens is great. If you only use tokens for stuff, you always need to find out the best route to the object anyway. So tokens are awesome because tokens get you to the user, and then you need to move forward from that. Another reason, I just stole some Django access model. I'm sorry for that. If this doesn't make sense, it does, but it's not really the thing. So place the access model where it makes sense for you, and stick to it. It's super easy to miss. In this case, this is more of a permission-based access model. So this basically just checks that this class is actually accessible by someone that has a to-do or add to-do credential. So this is not like a great example from Django in terms of being able to access your own objects. I would love to hear about suggestions to this or how you guys do it. Code review, and try not to miss this. And the reason why I have this picture is because I heard about a company that is doing it with, I think there's a word for it. Somebody here probably knows about it. But basically, you have a puppet next to your computer, and as soon as you commit stuff, you talk with the puppet, and you tell them, look, Code Monkey, right, or something like that. So, sorry. Okay, rubber ducky, yeah. So, and it works. Like, it was a gaming company in Sweden. They actually had that as a demand. Like, pick your own toy or whatever and talk to it, because you don't want to disturb everybody all the time. And you realize stuff. Like, you realize, like, hey, I missed this thing. A repetition about this. String comparison, that is not here. Just be that anyway, all right? IDORs are bad, extremely bad. It's easier to exploit, easy to find, and it's being exploited as we speak right now, and it's worth a lot of money, both to the black hats and also the white hats today. Numeric IDs, try to avoid them as much as possible. Stick to hashes or UIDs, and try to have a generic access model, and please review your code and talk with each other. Talk with each other. Sorry? Insecure direct object reference. I just made an abbreviation out of it. So that's it. Thank you. So before questions, is there anybody that realized something during this talk that, hey, I need to fix this or do something? You're sitting with the computer now also. That's awesome. That's great. Sorry? Yeah, okay. So not user IDs in cookies, but user session IDs. Yeah, you're right.
Questions, anyone?
What kind of user message would you suggest when someone tries to sign up with an email that already exists?
We have a solution that on Detectify, which basically means that we say, when you register, we say that, you now have an email. Like, we're going to send you an email. And if that user is already registered, we send them an email saying, just so you know, somebody tries to register to this account. If it's you, then you're already here. And if it's not you, please tell us. And then we have a please ban this IP thingy, so we know who actually did it and stuff. So that's one solution to it.
You said don't store user IDs and the like in cookies.
Yeah.
Use tokens instead.
Yeah.
Could you expand a little on what you mean by a token in that?
Yeah. So that was in regards to the example where they actually used the user ID inside the cookie to figure out who you were. And the problem with that is that the cookie data sent to the server is actually controllable by the user. You can modify that to whatever you want. And if you're using tokens, or if I go to sessions first, because the guy here mentioned that also. So sessions in that sort of sense is basically not guessable. You don't have numeric sessions. You have probably a hash generating a session. And that means that you can't really control, like you can modify that data, but that will end up in not being like a session which has a user ID in it. So this was a really bad example, and I don't think people are actually doing this anymore, putting user IDs in the cookies. And tokens is also a good thing because it's not really saying exactly what user it has. And because of that, you can actually use the token. Like if you have an API or something and you use the token, it needs to figure out who the user is. Okay, so the difference between having a user ID in the session and having a token is that's basically the same thing. So sorry if I like everything is better than user IDs in the cookies, I would say. So sorry for being confusing there.
Questions?
Yeah, like a lot of other people here, I'm sure, I have in the past discovered vulnerabilities with a couple of websites, somewhat accidentally, but I didn't do anything about disclosing them to anyone because I was concerned about what that may mean. And I just wanted to know if you had any advice about how to handle situations like that.
It's a hard thing. It all depends on the company that you find issues with. So there are some companies that, for example, HackerOne tries to solve this by being the middleman, which basically means that if you find an issue on a company that you know are like Oracle, that don't like security researchers, you don't go to them and knock their door and say that, hey, I have a vulnerability in your systems. So, and they try to be the middleman there. So you can go to like HackerOne and tell them or search for, they have like a directory of all the companies that have like responsible disclosure or being like just a contact email for security issues. So that's a good start. And then there's some organizations like EFF. I don't know if they're doing it at all, but there are some organizations that actually try to do this also, like being the middleman in between a security researcher and the company, because some companies can be grumpy, so, at least grumpy, yeah.
From one point of view, having a nice, clean REST API is a really good idea because everybody knows what's going on. You can work with the API very easily and so on. But from a security point of view, is that actually then a really bad idea because it reveals too much about the system you're interacting with?
In terms of what? The API?
Yeah, so for example, you've got /receipt, /view, /receipt, /update,
yeah.
You know, that kind of thing. That the language is very clear, the kind of object you're requesting, the kind of interaction you're making with it. You're automatically exposing a lot of information about the system that you're talking with. Yeah. And at what point, where's the tipping point in that you go, actually, let's not do it like that. Let's have /ABC97Z/2195.
Yeah, so I can, to answer the question, I can give you an example of a case where it was really obfuscated but didn't really matter. So Google had something called Google Voice. And Google Voice worked that, it was an API, but the API worked that you have two numeric parameters. And it was a matrix of methods. So using 2, 3, that means one method, and using 5, 11, that means another method. It doesn't really matter. Like if you try stuff out, and maybe that's a bad example because that's easy to test. But I would say like if you keep it easy on if you keep it simple on the outside, then you really need to make sure that you keep it easy on the back end as well. Like if you actually doing like read and update and stuff like that, you need to make sure that the access model actually handles you if you add another object and somebody realizes, hey, I can do /update to this and that will probably work. And so that is also an example of scenarios where you, like, some of the objects has read and update to them, or post or put or delete or anything. But some of the objects don't. But if you try it on them, stuff happens. So I would say, like, if you want it simple, please try to make sure that if you extend this to new stuff, that you don't forget that. Like, and that's why I'm talking about, like, one solution is to hide the access model. So it's there, but so we create new objects and it's automatically there. Like, and one solution is to have it super restrict, and you need to open it when you're building the object. So the object doesn't work because you need to open the access model, saying like, okay, we need to say that this should have read capabilities or update capabilities. So basically, we talk more about, like, instead of blacklisting, we do whitelisting. We allow exactly what's, yeah, that is one solution. If that was an answer, yeah. You're the guy.
We'll be close for time. Do we have enough time for one more question?
Yeah.
Just one more from me. What's been the biggest payout you've seen for this?
What's been the biggest payout you've seen
Payout,
for the shortest amount of time?
Yeah, I would say my own, of course. But that was just, it's a funny story. We were in Vegas for DEF CON, and one company invited us, a couple of guys, for hacking there, and they increased the amount of payouts because we were there and it was an event. So I spent 6.5 hours and made $52,000. So that was, and it's like Microsoft has this 100K for Internet Explorer, like sandbox bypass thing. So that's the biggest, but this was the coolest. Like being in Vegas in a suite hacking, like that was like a move. Yeah. No. I like this.
I'm afraid that's...
So I have stickers and some shirts if people want. It says "Go Hack Yourself" on it. So if you come by, I have a bunch. I don't have for everybody, but I have some shirts. Thanks.